Trigonometry, Chapter 5, Trigonometric Identities, Section 4, More Identities, Video 4, Using Double Angle Identities, Part 3. This series is based on content from Pearson's Trigonometry, the 12th edition, by Lial, Hornsby, Schneider, and Daniels. In the last video, we used double angle identities to verify new identities. Here you see a list of all of our double angle identities. In this video, we use double angle identities to simplify expressions. For example, simplify sine squared of 7x minus cosine squared of 7x. What does this look like? Notice this almost resembles a cosine double angle identity. Cosine of 2 theta equals cosine squared theta minus sine theta. But our expression starts with sine squared, whereas this identity starts with cosine squared. This is an easy problem to fix. To reverse a subtraction problem, factor out -1 and rearrange the terms. So we're going to take our sine squared 7x minus cosine squared 7x and factor out a -1. Doing so turns the sine squared negative and the cosine squared positive. Writing the cosine squared first and the negative sine squared second gives us something that resembles our double angle identity. So now we'll apply the cosine double angle identity. Cosine of 2 theta equals cosine squared theta minus sine squared theta, with theta equals 7x. And it's worth pointing out that the actual variable used here is irrelevant. You may be saying, you used theta here, but back here it's x's. The name of the variable is immaterial. The main reason I'm using theta here is because we've already used x in the given expression. Thus, when we do our substitution here, it's a little bit easier to say, change these thetas to 7x's. Now, in future videos, I won't switch variables for this convenience. Anyway, we apply the double angle formula to cosine squared of 7x minus sine squared of 7x. That becomes cosine of 2 times 7x. Well, that's just 14x. And don't forget, we have the negative in front when we factored out a -1 to reverse the subtraction problem. Therefore, sine squared of 7x minus cosine squared of 7x is negative cosine of 14x. Let's try another one, but numerical in nature. Evaluate sine of 15 degrees, cosine of 15 degrees. Which double angle identity does this resemble structurally? Notice this resembles the sine double angle identity. Our expression is the product of sine and cosine. Sine times cosine, sine times cosine. But it's not quite the sine double angle identity because the double angle sine identity has a coefficient of 2, which is not in our expression. So how can we make that 2 show up out of nowhere? That would be handy if it were there. To make a 2 appear out of nowhere as a coefficient, we balance it with the 1/2. Thus, here's what happens. Sine of 15 degrees times cosine of 15 degrees equals 1/2 times 2 sine 15 degrees cosine 50 degrees. This is what I casually refer to as uncanceling. Normally 1/2 times 2 cancels, but here we uncanceled it to create the 2 that we needed to use our sine double angle identity, which we'll do next. Our sine double angle identity says 2 sine of theta cosine of theta equals sine of 2 theta. Since theta is 15 degrees here, 2 theta is 30 degrees, so we have 1/2 times sine of 30 degrees. But the sine of 30 degrees is 1/2, and 1/2 times 1/2 is 1/4. So fairly straightforward. Once you know how to sneak that 2 in there. Now you try. Pause the video and work the following. Number 1, simplify for sine of x over 2 cosine of x over 2. Number 2, evaluate 2 tangent of pi over 8 over 1 minus tangent squared of pi over 8. All right, here's your fair warning if you haven't paused the video. Solutions in 3, 2, and 1. For the first one, notice we had a 4, but we wanted a 2. So this time, instead of uncanceling to create a 2, we simply factored a 2 out of the expression and then pushed the sine double angle formula forward, ending with 2 sine of x. For the second one, the structure of the expression clearly indicates that we're going to use the tangent double angle formula. The angle inside of the expression is pi over 8, so it gets doubled inside of tangent to become pi over 4, and tangent of pi over 4 is equal to 1.